Hello students. Now I am doing class for class 10. Let us do geometry. In the last online class also we were doing geometry. The last theorem was theorem number 5 and the theorems were related to the circle. So today also we will do theorems which are related to circles. Okay. So theorem 6 is prove that the opposite angles of a cyclic quadrilateral are supplementary. So first of all you should know cyclic quadrilateral. The सबभन्दा पहिला हामीलाई cyclic quadrilateral भनेको के हो यो चाहिँ थाहा हुनुपर्छ. You know cycle that means a circle, it is just like a circle. Cyclic quadrilateral, that means the quadrilateral inscribed in a circle is known as a cyclic quadrilateral. The quadrilateral inscribed in a circle is known as a cyclic quadrilateral. So it is related to the circle, right? Circle भित्र जुन चाहिँ quadrilateral बनाइन्छ त्यो फिगरलाई हामी के भन्छौं cyclic quadrilateral भनेर भन्छौं. त सर्कललाई हामी नेपालीबाट के भन्छौं वृत्त हैन. सर्कललाई हामी नेपालीबाट के भन्छौं वृत्त. क्वाड्रिलेटरललाई हामी नेपालीबाट भन्छौं चतुर्भुज. त्यो चतुर्भुज चाहिँ एउटा सर्कल भित्र बनायो भने चाहिँ त्यसलाई हामी के भन्छौं साइक्लिक क्वाड्रिलेटरल भन्छौं. कि the circle which passes through the four vertices of a quadrilateral is known as a cyclic quadrilateral. Okay, so we can draw the figure also. It is a circle, right? And a circle has a center, so this is the center of the circle, right? So now, inside the circle, you draw a quadrilateral. You know the meaning of quadrilateral? What is a quadrilateral? A quadrilateral is a plane figure bounded by four sides. That means it has four vertices. The quadrilateral has four vertices. Suppose this is A, B, C, D, right? So here the circle passes through the four vertices of the quadrilateral. That means the circle passes through the 4 points A, B, C and D. So this A, B, C, D is a cyclic quadrilateral. Okay. Now in this case you have to prove that the opposite angles of a cyclic quadrilateral are supplementary. Okay, so what is the meaning of supplementary? The two angles, suppose there are two angles. So this is A, B, this is C and this is D. So AB stands on the straight line DC. So this is one of the angles ABC and this is another angle ABD. So sum of these two angles is 180 degree. If the sum of the two angles is 180 degree, then this is known as supplementary angle. The two angles are said to be complementary to each other. Okay? If the sum of the two angles is 180 degree, then the two angles are said to be supplementary to each other, or they are known as supplementary angles. Okay, but if the sum of the two angles is 90 degree, then the two angles are said to be complementary or complementary angles. Then the two angles are said to be complementary angles if the sum of the two angles is equal to 90 degree. Okay, so what do you mean by supplementary angles? If the sum of the two angles is 180 degree, then the angles are said to be supplementary to each other. But if the sum of the two angles is equal to 90 degree, then the angles are said to be complementary to each other, right? So now in this case, you have to prove that the opposite angles of a cyclic quadrilateral are supplementary. So what do you mean by opposite angles? If you take this angle A, so its opposite angle is angle C. That is, if you take angle BAD, its opposite angle is angle BCD. You have to prove that the sum of these two opposite angles is supplementary. That means angle BAD plus angle BCD is equal to 180 degree. Okay. Again, you have to prove that sum of these two angles is also supplementary. That is, angle ABC plus angle ADC is equal to 180 degree. Supplementary angles means the sum of the two angles is equal to 180 degree. What are my complementary angles? The sum of the two angles is equal to 90 degree. Is that clear to all of you? Now let us prove it. Okay. Now we'll prove this theorem. Let us draw the figure. So again, I am drawing a circle here. So it is a circle. And circle at the center here, right? And let us draw the cyclic quadrilateral here. So this is a cyclic quadrilateral. तर तिमीले घरमा बनाउँदा चाहिँ तिमीले कम्पास पेन्सिल रुलर युज गर्नु ठीक छ राम्रो देख्छ So this is A, this is B, this is C and this is D. So here ABCD is a cyclic quadrilateral. So ABCD is a quadrilateral which is inscribed in a circle with the center O. That means ABCD is a cyclic quadrilateral. It is given. Okay. Now you have to prove that the sum of the two opposite angles, the opposite angles of a cyclic quadrilateral are supplementary. That means opposite angle of BAD is angle BCD. You have to prove that this sum of the two angles is equal to 180 degree. And this angle B and angle B are opposite angles. Their sum of the two angles is also 180 degree. You have to prove this relation. Right? So let us prove it. Now first of all, you have to write given. What is given here? ABCD is a quadrilateral. ABCD is a quadrilateral which is inscribed in a circle with the center O. With the center O. Right? That is ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. Okay? So now to prove. Now what is to be proved? The opposite angles of a cyclic quadrilateral are supplementary. That is, the sum of the opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary. It means that the sum of the two opposite angles of a cyclic quadrilateral are supplementary. Okay? So to prove, number one is angle BAD. If you take angle BAD, what is this opposite angle? This is the opposite angle, right? So angle BCD is equal to 180 degree, right? And similarly, you have to prove angle SDABC. If you take angle ABC, which is its opposite angle? Angle ADC. That is, angle ADC is equal to 180 degree. Okay? So next, construction. You have to do the construction out here. Again, you have to draw some figure out there. So in order to prove angle BAD plus angle BCD is equal to 180 degree, let us join O comma A and O comma D. Okay? So construction B comma O and D comma O are joined. हामीले यहाँ के गर्यौं? B र O जोइन गर्यौं अनि फेरि O र D पनि जोइन गर्यौं. अब यहाँ हामी के गर्छौं भन्दाखेरि अब प्रुफ अब हामीले प्रमाण गर्नुपर्छ त प्रमाण गर्दाखेरि हामी प्रिभियस थ्योरम चाहिँ युज गर्छौं जस्तै यहाँ के छ भने भन्दाखेरि यो बीसीडी एउटा आर्क अफ ए सर्कल हो यस्तो घुमिएको छ यो घुमिएको चाहिँ के हो बीसीडी इज एन आर्क अफ ए सर्कल दैट इज अ पार्ट अफ द सर्कल ओके सो दिस बीसीडी इज एन आर्क दिस बीएडी यो जुन चाहिँ भन्छ यो पनि एउटा आर्कै हो ठीक छ त अब हामी प्रिभियस थ्योरमबाट हामी के लेख्न सक्छौं भन्दाखेरि angle BOD is the angle at the center O of the circle subtended by the arc BCD. Also, angle BAD, this angle BAD is the angle subtended at the remaining part of the circle subtended by the same arc BCD. So, from previous theorem you can write down that this angle BOD is equal to twice angle BAD. Now we will write down that one. Okay? So let us write it. Now proof. Let us do the proof now. Proof. Angle BOD is the angle at the center O of the circle subtended by the arc BCD and angle BAD right, and angle BAD. What is that? Angle BAD is the angle at the remaining part of the circle. So this is the remaining part of the circle subtended by the same arc BCD. We will write here. And angle BAD is the angle at the remaining part of the circle subtended by the same arc, BCD. Okay, so I think you have understood it. So we are using previous theorem now. So from previous theorem, what can we write? Angle BOD. Angle BOD is equal to twice angle BAD. Is that clear? Now take these two to the left hand side. So what do we get? If we take these two to the left hand side, it becomes half angle BOD is equal to angle BAD. अब हामी के गर्छौं यो राइट साइड को लेफ्ट साइड को राइट साइड मा लेख्दाखेरि साइन चेन्ज गर्नु पर्दैन or angle BAD is equal to half angle BOD. Suppose this is number 1. Okay, so I think I've understood it. Again, now in the reverse way, now we will take an arc BAD. Now this is also an arc BAD. This is a part of the circle, right? So now let us take this reflex angle BOD, that is the remaining angle of BOD. In the first part we took this angle, isn't it? Now this is the reflex angle BOD, that is the remaining part of the angle BOD. Now this is reflex angle. So outside this angle BOD is the angle that we took in the first part. Now this is the reflex angle BOD. This is the reflex angle BOD. That is the remaining part of the angle. Okay. Now reflex angle BOD at the center. Reflex angle BOD is the angle at the center. Subtended by the arc BAD. Okay, subtended by the arc BAD. Is that clear? And again, angle BCD is the angle at the remaining part of the circle subtended by the same arc BAD. So in this case also we can write down that this reflex angle BOD is equal to twice angle BCD. So again we will write down here. Again, since this angle BOD is this angle, now this is the remaining part of the angle BOD, that is known as the reflex angle. So here we can write reflex angle BOD is the angle at the center O, is the angle at the center O of the circle subtended by the arc BAD, subtended by the arc BAD, right? So again, reflex angle BOD is the angle at the center O of the circle subtended by the arc BAD. And now let us take this angle BCD, and angle BCD is the angle at the remaining, since there is no space here, so I wrote it here, REMAINING. So an angle BCD is the angle at the remaining part of the circle, subtended by the same arc, BAD. Okay, is that understood now? So what can you write from the previous theorem here also? Therefore, let us write reflex angle. Since this is angle BOD is this one, and reflex angle is this opposite angle, right? So reflex angle BOD is equal to twice angle BCD. So this reflex angle BOD will be twice angle BCD. So I think I've understood it. Okay. Next, let us simplify it. Now let us take these two to the left hand side. It goes to the denominator on the left hand side. So it is half. Then reflex angle BOD is equal to, on the right hand side you write angle BCD. अच्छा यसमा पनि हामी के गर्छौं, लेफ्ट साइड को राइट साइड मा, राइट साइड को लेफ्ट साइड मा लेख्दाखेरि साइन चेन्ज गर्नु परेन. सो angle BCD is equal to half reflex angle BOD. Is that clear? So let us mark it number 2. Suppose this is number 2. Okay. So we got here number 1 as well as number 2. This is number 1 and that is number 2. We marked it as number 1 and we marked that as number 2. So let us add them, because you have to prove that angle BAD plus angle BCD is equal to 180 degree. That means you have to add these number 1 and number 2. If you add number 1 and number 2, you have to add these left hand side is equal to, you have to add those right hand sides. So let us write adding 1 and 2. So adding 1 and 2, what do we get? So let us add those left hand sides. That is angle BAD. From number 1 we have angle BAD, plus from number 2 on the left hand side we have angle BCD is equal to. Now on the right hand side, what will you write? What is right hand side on number 1? This is half angle BOD. Half angle BOD plus. Next, right hand side on number 2 is half reflex angle. Half reflex angle BOD. Is that clear? So now we can add them. So let us write left hand side as it is, angle BAD plus angle BCD is equal to, now there is common. What is common there? Half half is common within bracket, angle BOD plus reflex angle BOD, reflex angle BOD, right? Or angle BAD plus angle BCD is equal to half into. So now what is angle BOD plus reflex angle BOD? What is this angle BOD plus reflex angle, that is revealing angle BOD is equal to, that is your 360 degrees, isn't it? Suppose there is a point. So what is the whole angle around this point? This will be your 360 degree. You know that if you draw a straight line, if you mark this point, so this angle, a straight angle will be 180 degree and this angle is also 180 degree, right? So 180 plus 180 is 360. So what is the angle around this point? It is 360 degree. That is 180 plus 180 is equal to 360 degree. So we can write here, this angle BOD is this angle and reflex angle BOD is this remaining angle. If you add these two angles, you will get 360 degree. So it is 360 degree. Is that clear? So you can cancel it. It goes 180 degrees. So or angle BAD plus angle BCD is equal to what? It is 180 degree. That is proved. Now what is to be proved? You have to prove that this angle ABC plus angle ADC is also 180 degree. So you can write similarly, we can prove. Similarly, by joining O comma A and O comma C, it can be proved that angle ABC plus angle ADC is equal to 180 degree. You can write it here similarly. So you can write here similarly by joining O comma A and O comma C, it can be proved that what can we prove? Angle ABC plus angle ADC plus angle ADC, angle ABC plus angle ADC is equal to 180 degrees. So we have proved it. In the second part, you can write similarly. So similarly, by joining O comma A and O comma C, it can be proved that angle ABC plus angle ADC is equal to 180 degree. So you can copy it. We'll do the next theorem. So now we are doing application number 1. This is the application of that theorem that we have just done now. Okay. So application number 1 is, what is the question out here? If any side of a cyclic quadrilateral be extended, any one side of a cyclic quadrilateral is produced. The exterior angle so formed is equal to the interior opposite angle. Let us prove it with reason. You have to prove that the exterior angle so formed is equal to the interior opposite angle. So let us draw the figure and then try to understand it. Okay. So again, a cyclic quadrilateral is there again. That means you know cyclic quadrilateral now, right? You know cyclic quadrilateral. What is a cyclic quadrilateral? A quadrilateral inscribed in a circle is known as a cyclic quadrilateral, right? So now let us draw the quadrilateral inside this circle. So A, B, C, D. That is the quadrilateral ABCD is inscribed in a circle, right? And now any one side of a cyclic quadrilateral is extended. So let us take one of the side as BC and let us produce this BC up to the point E. Now, since this angle DCE is outside the circle or outside the quadrilateral, so this is known as exterior angle. This is known as what? Exterior angle. And these are the interior angles. That is, angles of the quadrilateral are known as interior angles. But in this case, it is given that interior opposite angle. That is, interior opposite angle is this one. Your angle DCE को interior opposite angle से कुछ है angle BAD. Not this one, angle DCB पनि भएन, angle ABC पनि होइन, angle ADC पनि होइन. त यो angle DCE को interior opposite angle चाहिँ कुन चाहिँ हो? Angle BAD. Understood? Now you have to prove that the exterior angle so formed will be equal to the interior opposite angle. That means you have to prove this angle DCE is equal to angle BAD. Is that clear to all of you? Now, ABCD is a cyclic quadrilateral here. The side BC of the cyclic quadrilateral is extended up to the point E. So, angle DCE is the exterior angle. You have to prove that this angle DCE is equal to angle BAD. Okay? This angle DCE will be equal to angle BAD. You have to prove this relation. That means angle DCE is equal to angle BAD. Is that clear? So write down. Given here is, so what is given part? ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. Okay. Then the side BC of the cyclic quadrilateral is produced up to the point E. So given here is ABCD is a cyclic quadrilateral. The side BC of the cyclic quadrilateral is produced up to the point E. Okay. So now to prove अब हामी के प्रमाण गर्छौं? हामी प्रमाण गर्नुपर्छ exterior angle, which is the exterior angle here, angle DCE is equal to interior opposite angle. That is interior opposite angle that is BAD. That is angle BAD. Is that clear now? You have to prove that exterior angle DCE is equal to interior opposite angle BAD. So I think you have understood this application number 1. So let us prove it now. Now let us do the proof part now. So in this case, you don't have to do any construction out here. Other than this figure, you don't have to draw any figure out there. Okay? So no construction part is needed here. Okay? Now let us prove that this exterior angle DCE is equal to interior opposite angle BAD. Right? Now how do you prove it? In the previous theorem, we just proved that if ABCD is a cyclic quadrilateral, then the sum of the opposite angles of the cyclic quadrilateral are supplementary. Just now we proved it, isn't it? So since this therefore opposite, it is meant as since. Okay? So therefore opposite since ABCD since ABCD is a cyclic quadrilateral, since ABCD is a cyclic quadrilateral, since ABCD is a cyclic quadrilateral, therefore what can I write? Angle BAD plus, that is angle BAD plus its opposite angle is angle BCD, plus angle BCD is equal to 180 degree. Is that clear? So we can write it from the previous theorem. Is that clear? So next, again, look at the figure. Now in this case, this B is a straight line, DC is another straight line, but this straight line DC stands on BE. That is, you can write down that sum of these two angles is also 180 degree. That is, sum of the angles of angle DCE plus angle BCD is also what? 180 degree, because this is the straight line, isn't it? And on this straight line, this DC stands, and the sum of these two angles will be equal to 180 degree. Okay? Now, the straight line, DC stands on the straight line BE at the point C, on it, So what can you write here again? Therefore, angle DCE plus angle this BCD plus angle BCD is equal to 180 degree. Okay? So let us mark it number 1, let us mark it number 2. Now, if we compare these two, now from 1 and 2, if the right hand sides are equal, from 1 and 2, if these right hand sides are equal, left hand sides must be equal. So from 1 and 2, what can I write? These left hand sides are also equal. So here we can write from 1 and 2, comma, we have, so I already told you that if the right hand sides are equal, left hand sides must be equal. So from 1 and 2 we have, therefore angle BAD plus angle BCD is equal to what? Angle BCE plus angle BCD. So this is an equation, right? And in this equation, on the left hand side and on the right hand side, you cancel the similar terms. You can cancel the similar terms. So what are the remaining angles here now? That is angle BAD is equal to angle DCE. So we have proved it. Right? That is angle BAD is equal to angle DCE. That means the interior opposite angle BAD is equal to exterior angle DCE, or exterior angle DCE is equal to, this is interior opposite angle BAD. So we have proved it. Okay? So you can copy it. Now we'll do the next theorem or application. Now we are doing application number 2. You have to prove that a cyclic parallelogram is a rectangular figure. Cyclic parallelogram means a parallelogram is inscribed in a circle. You have to prove that that cyclic parallelogram is a rectangular figure. Okay? So you know parallelogram, isn't it? Parallelogram whose opposite sides are equal and parallel, right? This is a parallelogram, you know that. ABCD is a parallelogram whose opposite sides are equal and parallel. But this angle is not 90 degree. These angles are not 90 degree. But in case of rectangular figure, this is a rectangle whose opposite sides are equal and parallel. But if one of the angle is 90 degree, all the angles will be automatically 90 degree. And this figure is known as what? Rectangle. This figure is known as what? This is a rectangle and this is the parallelogram. So is that understood? So you've done it in class 7, 5, 6, 7, like that, isn't it? So now let us prove this application number 2. So you have to prove that a cyclic parallelogram, that is a parallelogram inscribed in a circle, is a rectangular figure, right? So let us draw the figure now. So it is a circle, right? It is a circle, and inside the circle you have to draw a parallelogram. Parallelogram means whose opposite sides are equal and parallel. So this ABCD is a cyclic parallelogram. That means these opposite sides are equal and parallel. So ABCD is a parallelogram and it is inscribed in a circle, right? Now write all the given part. So what is given here? A parallelogram or cyclic parallelogram, or you may write a parallelogram ABCD. A parallelogram ABCD is inscribed in a circle. That's why this parallelogram is known as cyclic parallelogram, right? So next, to prove, what is to be proved? ABCD is a rectangular figure. ABCD is a rectangular figure. So now in this case also no construction is needed. Okay, no construction is needed in this figure now. So now directly we will do proof part. Now since ABCD is a parallelogram, so in case of parallelogram their opposite angles are equal. So since ABCD, so here also I have written therefore opposite. This therefore opposite means since. Okay, हामीले यो जुन चाहिँ therefore उल्टा पाराले लेख्छौं त्यसलाई चाहिँ हामी के भन्छौं? Since भनेर भन्छौं. Because, since भनेको because of. Since ABCD is a parallelogram, therefore what can I write? Their opposite angles are also equal, that is angle ADC is equal to angle ABC. That is angle ADC, this angle is equal to this angle. यो दुईटा एंगल इक्वल पनि हुन्छ तर हामीले एउटा पार्ट मात्रै लेख्यौं यसमा, एउटा पार्ट मात्रै चाहिन्छ. That is angle ADC is equal to angle ABC. Okay? So now, since it is a cyclic parallelogram or cyclic quadrilateral, isn't it? A parallelogram is also known as a quadrilateral because it is also bounded by 4 sides. Okay? So now, since ABCD is a cyclic parallelogram, therefore the opposite angles of a cyclic parallelogram are supplementary. That means angle ADC plus angle ABC is equal to 180 degree. Therefore angle ADC plus angle ABC is equal to what? It is 180 degree. Just now we proved this theorem, right? So again, angle ADC is equal to angle ABC. So instead of angle ADC, we can write angle ABC from there. So here you write angle ABC plus angle ABC is equal to, what is it? It is 180 degree, right? So angle ABC plus angle ABC is same angle, twice angle ABC is equal to, it is 180 degree, or angle ABC is equal to 180 degree divided by 2. Or what can you write? Angle ABC is equal to, what is here? This is 90 degree. So since one angle is 90 degree, so automatically all the angles will be 90 degree. That means this cyclic parallelogram ABCD is a rectangle. So hence the cyclic parallelogram ABCD is a rectangle. Okay, so hence the cyclic parallelogram ABCD is a rectangle, because one of the angles of the cyclic parallelogram is 90 degree. If one of the angle is 90 degree, automatically all the angles will be, it will be 90 degree. So if one of the angles of the cyclic parallelogram is 90 degree, then the cyclic parallelogram ABCD is a rectangle. Is that clear? So it is proved. Okay. So now also this much is for today. So in the next class we'll do more problems. We'll do theorems on tangent. We'll do theorems on tangent to a circle in the next class. Okay. So you can copy it.